So be careful what you wish for, because if you try too hard for business agility, you may find yourself locked into patterns that you didn't intend to do. It all starts with a business process. And isn't it wonderful? A nice, simple thing. This is immediately recognizable by everybody. It can be programmed by a citizen coder without any coding, without any programming. But the reality is that your business process is going to look a little bit more like this. And you all know this because you've been doing business process management for a long time. And to say that there's no coding here at all is not really being honest. And we can quibble about whether it's better to do this with bpmN or CMMN or some other thing. There's a deeper underlying problem, and that is that all of these people that are involved in this have a stake in this process. And you know what? They all want control. They all want to make sure that this process doesn't change unless they've got their stamp of approval on it and that their parts of the process are satisfied. And it goes like this. There's a lot of basically arguing about the process, figuring out what the process is going to be, and then you reach an agreement. And there's an implicit assumption that after you make that agreement, there's not going to be any changes. Believe me, try going 2 weeks later and saying we want to make this change. Doesn't work. So let's throw all that out, and let's think instead about defining all the tasks that need to be done in an organization. Now let's define all the people who do those tasks and the requirements around the tasks. And then what we can do is have the system find an optimized route through all of these, through your organization to complete your work. We can optimize this according to who's available and the individual case and all sorts of things like that. So that's our goal. It's a little bit like the way a GPS does it when you're driving on a map. So let me dig into how this works. I'll give you a few details on this. We don't normally with ESP start with a business process diagram and decompose it, but it's easier to explain it that way. And my monitor is coming and going. The process can be decomposed into a set of service descriptions. And the service description tells you a task, and it tells you the required tasks that have to be done before that. And you'll notice that all of the tasks that are there listed as required tasks. Now in the actual demo, you'll see a service description displayed like this. You see the task, you see the person doing it, and you see the required data, required task conditions that have to be done before that. Now taking this service description and a whole collection of these across the organization, and notice that I've left some of the requirements out. We can then generate the process, and the process is a little bit different here, but it's okay because it meets all of the individual service description requirements. Now notice if somebody was to add a task to their service description, the effect of that in the generated process is that you'll have an additional task in the process. So you can add a task by adding it to your service description. Also, if somebody was to decide to remove a task from their requirement so it's no longer needed, again, the generated process is going to be simpler. So by changing the service description, you can change the process, but you've met everybody's explicitly stated requirements. We can also deploy this through a set of distributed agents, and the agents talk to each other over a protocol, and they basically work out what the optimized process is that goes through the organization. The protocol involves these 7 steps, and the only thing to take away from this is that you don't resolve the whole process and then execute it, but actually the process is being resolved while you're executing the first few steps of the process. It figures out what the rest of the process is going to be, and it could be affected by the beginning. So here's the benefits. Service descriptions can be changed. The synthesized processes always meet everybody's requirements. They can be optimized for individual cases, and this can be used for cross-organization or in-organization processes. And this enables a kind of a gig economy. All of these organizations are about freelance workers, how to make people available for doing specific tasks and specific processes. Wouldn't it be great if our process systems could bring in these freelancers into our processes? That's our goal. The use case today I'll be presenting is this travel authorization. It's a simple process, but it is a real process that is in use today. And I think that's the important takeaway on that. It generates processes that look like this. So these are actual generated processes. They're always linear. So we always generate a linear process. There are conditions in there, but those conditions are taken care of at the process synthesis time. So if something changes, you'll get a different synthesized process. The book, Beyond the Business Process Model, is my attempt to write all of these details down so that we can get the terminology straight and get all the ideas straight for those people who want to implement emergent synthetic processes. Okay, so this is Travel App. The genesis of this was that Fujitsu Caribbean, all of Fujitsu has a rule that if you're going to travel international, you have to get approval for international travel. And the thing is that in the Caribbean, every trip they take is an international trip. So they basically had to get approval for every trip. And we implemented a standard BPM process. It's a very straightforward process. It's not that difficult. They've ran with that for a few years. But then they merged with the Fujitsu Mexico organization. And the thing about the Fujitsu Mexico organization is they don't have departments, so their process was a little bit different. So we needed to change the process for them, but the people in the Caribbean didn't want to change the process because the process was already working for them. So this was an excellent case to say, well, look, why can't we make a system that allows each part of the organization to be responsible for their part and have it automatically change and adapt? And so that's why we implemented this. In here, it's a fairly straightforward applications. What I'm going to do is I'm going to generate some test data here because I'm too lazy to type it all in. And we can see this is from the Fujitsu Caribbean here. And there's one of the things they do in the process, kind of nice, is that they estimate the travel costs before they do the approvals. So, I mean, that sort of makes sense. And sometimes they'll have an expert in who knows about travel and knows how much it'll cost. So the expert comes in and does this assessment, and then it goes on to the rest of the approvals. All I'm going to do here is save these changes. By doing the save, it will actually generate the process for me. So here's the process. Oh, that's a special situation which I can run into if I choose the wrong manager. So let me just change the management and save it again. Special error case. And okay. It's always demo effect, isn't it? It's great. I've done this demo 10 times recently and haven't run into that case. All right, so there's the simplified process. It's very short here because the amount of the travel, the cost of the travel is pretty low. So let me go back and change that. Let me jump the cost of the travel up and save the changes, and then you'll see that the generated pass is now more complicated. It has more steps in it. And the main process is that the CEO does an approval and the CFO does an approval, and then department and manager, and then they have this person do the travel review. So it's set now. If you have, let me set this to Melissa and save that. There's a dependency graph which shows, here's the goal. So it starts from the goal. You want to have travel booked for you. And so this is the dependency. So the sort of the corporate travel booking basically says that the CEO needs to approve it, and the CEO is saying that the CFO has to approve it. And this is the dependency graph that drives the whole process. And probably the best way to see it is this, which is, we actually start here with the requirement, and then the CEO requires the CFO. And this green line, these are all the people that can do the various tasks, the various roles in this process. And the green line here indicates the optimized route that has been found through the process. So now let's dig into it and see how this is done a little bit. If I go look at the service descriptions, so the service descriptions can be entered in here, and we'll look at the service description for Mervyn. So Mervyn does 4 different services. He does 4 different tasks he might do. He's not only CEO, he's also a manager, and he's also department head. And then this is, again, the depiction that we do here of the task that's done, the person who's doing it, and then we can have required tasks, we can have required data, we can have data conditions. So his data condition here is that the company name is not Fujitsu Mexico. So And so this will basically, by saying from the CEO, we have to get the CFO, it's then going to go search for somebody who can do that task. It's going to find all the people that can do the CFO, and then it's going to find the conditions. It's going to backwards chain all the way back to, if you remember, I think it was Leanne. We had, not Leanne, was it Leanne? It was not Leanne. I changed it so when you get back to the beginning, you have this task, travel review, and there are no required tasks before this. So since there's nothing required before this, that's where you can start the process. So let's go back and take a look at that. We start here in travel review, and then it was Melissa. I can show you Melissa's, but it's the same. And then you work your way through. So it's kind of like goal seeking. Your goal is to make the travel approval, and then we find out a way to do it. So, and this also depends on, some other attributes of it. For example, in this case, we're going with the Caribbean. But if we go back to the import form and we change it from the Caribbean to Mexico, I'm sorry, look at this closely. We have 6 columns here. So if I change this from Caribbean to the Mexico organization, remember their process was a little bit different. Now the trace log is only going to have 5 columns, because what we've done is we've effectively removed a task from the process, because the Mexican organization doesn't require department approval, so there's no departments there. Similarly, an individual can change their service description and add a task to the process. So if I go down here and I look at Leanne's, okay, so now Leanne's service, oh, that is very interesting. What happened there? I'm gonna restart this browser. Wow, what is this? Demo effect? I haven't ever seen it do that. All right, I'm gonna refresh this screen and hopefully I can stay on this. All right. So with Leanne does the travel review task. But for Leanne, what we've added is a requirement for a task called creative basket weaving, and I called it that so that you knew it was a trivial, frivolous example used for the demo. But she added this requirement for basket weaving, and then you need to do one more thing. You need to have a person who will actually do that task. So we set up Keisha as actually doing basket weaving. There's no requirements on that. So all we need to do is go back to the original form, which I lost because I refreshed it, but we can regenerate the data again here. And if we choose down here Leanne and we save it, what we have in the trace log now includes a column here for creative basket weaving. So we have added a task to the process, and then the system went out and found someone who could actually do that task. So that's essentially what we're showing here. Once we've found the process, we can work our way. We can step through the process. Enactment is very much like enactment in any other system. We send an email out to people. They come into the system. They complete the task. It moves on to the next person. And as you complete these tasks, these become history, and history becomes fixed. But we potentially are still generating the future part of the task. So if your CEO changes to somebody else before the process is finished, we'll then regenerate it again with the new CEO, and then we'll finish up the task that way. Okay, so that's essentially the demo. I'm just trying to get this idea out there. I did a demo in academic conference last fall, which was pretty much the same as this. I've been asking everybody, have you seen anything like this? Have you seen anything that you specify the tasks and the requirements on them, and then we generate the process from it? And basically people are telling me no, they've never seen this. So I don't know, maybe it's very new. Maybe it's a new concept, and it certainly works for this process, and I think it's gonna work for a lot of processes, so we'll see. So with that, I'll open it up to questions. Scott.
This is cool, and I haven't seen
Yep.
So I think you may have just at the end there answered a couple of these, but I'm not sure I understood. So task assignment, I'm a little confused at the definition versus instance distinction here. You say, well, we're going to generate this process.
Yep.
But I'm not editing the process to like launch the process, right? Like when I launch the process, I'm launching it, and at that time, that's when you're doing the synthesis, and then you assign tasks.
Yep.
All the way through the end of the process.
Well, okay, so we do. So your question is about the difference between instances and definitions. So we are generating the process definition for every instance. So we don't actually generate a process definition and then keep it. We're always and every time you do a save, it regenerates the process, and but it fixes what's been in history. So if you've already completed some tasks, those are fixed, but we're regenerating everything else.
Sure. And what causes you to reevaluate that path, right? Because presumably, and you said this, presumably the future assignees, this might be a year-long process, right? The
Yes.
future assignees may be different.
Right.
And we haven't talked yet about the sort of the determination of who it is. Like I'm not sure I'm clear on how you're determining that. But the future ones may be different. It clearly changes. What triggers the reevaluation of that? Are you just doing it continuously, or is there some event or something like that?
So I think the best way to think of it is it's continuously reevaluating it. I mean, honestly, we only do it when we save it. We have a mechanism that at 3 in the morning it goes through and reevaluates all the process definitions. But then at the same time, if you have a process that involves one person doing 3 different tasks and you want them all to be the same, then that becomes part of the data, and that data is driving the regeneration of the process, right? So because it's regenerated, it doesn't necessarily change anything. You set it up to regenerate the same way if you need it to.
Sure. But if you set, sorry, if you want to manually set one of these, right, you want to say, yeah, I know you picked Adrian for this one, but I really want it to be Evan.
Yeah, so that's what we're doing. We're actually doing here in this particular selector is selecting the person that's going to do the task. So we made that a data item in the form, and if I pick Melissa, and I save the changes, the new generated process will now have Melissa doing this step.
Okay, and then that's going to be fixed, right? You're not going to reevaluate that later?
If it's part of the data, no, that becomes fixed.
Okay. All right, well, I have a bunch of questions, but I'll let other people ask them.
Denis.
So we have a backward chaining pattern. So this is, as you look at the unification algorithm from Prolog?
No, so we could get very, very sophisticated in this. Now, the fundamental idea I wanted to present here is the idea that you are defining service descriptions and not the process. And then from there, we're going to generate the process. Now, we can do that a bunch of different ways. This is a fairly simple process, so we do a very simple backwards chaining. And in fact, we don't even do much optimization. In this implementation, it's a single server implementation. It's running on Mongo through Node, and of course, Angular as the front end. It's a very simple one. But what I'm expecting is that over time, we can get more and more sophisticated about how we generate the process and how we optimize the process, how we take into account how much time a particular worker has available. Because it might be that 3 of these people could do it, and one of them has nothing on their plate, and the other 2 are relatively full. We would then want to pick that person, and then we would get automatic resource load balancing and all sorts of things like that. So there's an open-ended list of optimizations that could be done. We haven't attempted to
Fundamentally, I guess, I don't know if you thought about it in your book or looking forward, but when you fall into collaboration, communication, then you're recreating role activity diagrams.
This could be very much like a role activity diagram. It's kind of similar to that. One thing I wanted to mention that I didn't talk about is that when you go to generate this, it can fail to generate. And there's 2 primary ways that it'll fail. One is that you can have a requirement for a task and nobody's doing the task. And in that case, it has to bubble up as an exception And you have to have a manager that come in and find someone to do that. So my example is you've got salesperson for the East Coast and salesperson for the West Coast, but an opportunity comes up in the Midwest. There's no one to do it. The manager has to jump in there, find somebody, create the service description, and then once you create that, in the future cases will pick that up. The other error condition is a deadlock, and that's where person A requires person B to do something and person B requires person A to do something. And again, it has to bubble up. The manager has to resolve that problem in the service descriptions, and then from then on it's resolved. So in a certain sense, it changes the manager from distributing tasks to people to creating service descriptions that automatically distribute tasks to people. Sorry, here.
So, as you mentioned, you generate behavior execution.
Yeah.
Given that this is a partial order, and you could leverage the fact that you could wait for this one first,
Yes.
so that you could do it in parallel.
Yes. Yeah, okay. So we purposely didn't put parallelism in here because this process didn't warrant having people working, because it doesn't really matter. So we just pick one order or the other. So when we see tasks in parallel, we arbitrarily choose one order. But you're right. You could get more sophisticated and offer the task to both people at the same time.
What's the main driver for actually generating the process? Because you could teach an engine to do a lot of that on the fly, as in the evaluation of preconditions, etc.
Yeah.
One of the, it makes it very declarative, which is great for adding new data to it.
Correct.
Add more data to it. It's more difficult to understand what's actually going on. So is this, the generation of the process, is that more for the users who will be running through it to visualize actually what's happening, or is it more to, because from a technology point of view, you're using more an engine that will then step through the steps, and that's why you generate the process, because that's how it's going to be executed. So it's more for visualization for your end users, or from a technology point of view to be able to execute the service.
So I think your question is, why are we generating this full process? Because at every step, we could just at that point in time decide what the next step is. And the reason we did that is because to debug your service descriptions. Because as you're creating the service descriptions, you're going to want to be able to do tests and trials. Like, well, here's a case. You want to run your last 100 cases in there and make sure that your service descriptions still create valid process definitions for this. So, and again, remember, it's very easy to just draw a process diagram. You know, if you say, do A, then B, then C, you've simplified the job. This is not simpler. This is a little harder. You have to create service descriptions with the right rules that drive all this stuff. So a little bit harder. You need to do that debugging and testing. But if you do that, the promise is that you then have self-optimizing processes that come out of it. So that's the reason.
Sorry, I see a lot of also synergy between this and CMMN, because that way to define, you could put centuries that are like, could fire at the same time, and that engine could even do it in parallel.
Yes, okay. So CMMN is a little more declarative, and this is declarative is, I think, probably even more declarative, but that's an opinion. Again, if you draw a combined process diagram, and that diagram has tasks from multiple people on it, then those people are stakeholders in that diagram. It becomes hard to change the diagram without getting the approval of all the stakeholders. By what we're doing here is we're saying there's only one stakeholder in this service description, and by removing it or by making it a single stakeholder, then that stakeholder can change this whenever they want to. That was the goal. CMMN doesn't quite do that.